Hi, I'm Dory Lyon with For the Greener Good, and I have here David Burdick, who is the visionary behind Earth Harmony Habitats. So welcome to the Greener Good.
Thank you.
Yeah.
Pleasure being here.
Wonderful. So it's nice to have you take your time out to be with us tonight. So can you explain to us a little bit about Earth Harmony Habitats?
So Earth Harmony Habitats is a set of homes that live within an equitable share of Earth's carrying capacity. In other words, it captures all of its own rain for water, captures all of its own sun for energy, and grows all of its own vegetables. And there are a set of homes that are built, the idea being it would be a community of 4 or 16, depending on what your size is. It all is designed to fit on 5,000 square feet or a standard city plot, 50 by 100 feet.
So like on an average city block, about how many of them would fit on an average city block for my
Well,
vision?
that's a pretty large area.
Yeah.
But if you just take one lot, which is just 50 feet in front, and then usually they're about 100 feet deep, you could put 4 of those on there. So if you can get 10 houses on a block, you could get 40 of these on just that one street.
Okay.
So.
Wow. All right. So are those some of the homes right there that your prototype?
As a matter of fact, they are. This is Earth Harmony Habitats. They basically are an octagonal home that uses SIP panels, which are structured, integrated panels that support the building, and it has a flat roof so that you can also utilize the roof. Mm-hmm. It has walls that are also utilized as gardens. It has a basement that's utilized as a cistern. So it's quite an ingenious design that works well with nature. And that's the whole idea, is that you're in harmony with nature, as opposed to taking water from an aquifer or energy from a coal plant.
Okay. And do you mind explaining to us from the ground up exactly how they work and
Absolutely.
What are the parts?
So it basically starts out with a cistern in the basement. And that's concrete. It's about an 8,000 gallon cistern, and it holds water that you collect in the Portland area over the course of the year. And we get about 36 inches of water, rainwater a year, and that would fill up about an 8,000 gallon tank. And that turns into, with 3 people, about 3 gallons or 10 gallons per person per day. Now that's not a very much water relative to what people are used to, which is anywhere between 30 and 75 gallons of water a day just in their homes per person. And if you're watering your yard, you normally double that in terms of amount of water you use. So bringing it down to 30 gallons of water per person per day is a challenge. And so there's some aspects of Earth Harmony Habitats that deal with that. 2 in particular is the shower. There's a shower that sort of recirculates water. Instead of water just running over your body and then going down a drain, it goes into a little reservoir, and then that gets warmed up and recirculated through the shower head. You can stay in there as long as you'd like, and use about 1.5 gallons of water. So that's one way to bring your water use down. The other way is to have a composting toilet. And composting toilets don't flush, and so you're using about 25 gallons of water a day when you flush. And here there's 0 water. So that's what we do to make this system really have a comfortable lifestyle and yet not require a lot of water. And so that's one part of it. See, these are not huge structures, so they don't have a big roof area, so you can't collect all that much water. So they're only 900 square feet, and each floor is around 300 square feet. And so that's roughly, when you take the awnings and whatnot, you have about 500 square feet of water collection. The other part that makes this a net zero structure, impact structure, is the solar panels that are on the top. That's enough to be able to collect all the energy that you need in a day. And basically it's averaged over the year, so that in the summer is collecting quite a bit of energy compared to what you're using. In the winter we don't have a lot of cloud cover, so you're drawing from the grid in the winter more than you're actually able to collect. But overall you have about what they call a net zero situation.
Wow.
And another part of this design is the walls. And the walls are made out of SIP panels, which is just 12 inches of foam, and then some OSB wood on both ends. And that OSB foam sandwich can actually support weight and load. And so you don't need to have an internal frame structure in the design. And that offers you an economy of scale for building. It doesn't use that much wood, and it's a lot less expensive to build. So that envelope itself runs about $30,000 for the 3-story.
Wow.
Right, just for the envelope itself.
Right. So tell us about the ventilation and how that works.
Okay, so part of the idea of this home is to be very draft free. And when you do a draft free, you need to put in some way for the system or the house to breathe. The analogy is you're not breathing through your ears anymore, you're breathing through your lungs and your mouth. And that's what they call a heat recovery ventilator. And the heat recovery ventilator works on a rather simple principle of passing air through a membrane which transfers the warmed air that's going out, the stale warm air, into the fresh cool air through that membrane. So there's not an air transfer, but there's a heat transfer. And then that goes back into the house, and now you have fresh air, a lot of fresh air, over the course of the house. And so I've got one in my home. It's a great way to bring down the humidity of the home and have just great quality air.
And what are they called, those ventilation?
Heat recovery ventilators, or HRVs for short.
Great. And I've noticed they're circular or they're octagonal?
Right, so the octagonal idea comes from how do you make kind of an interesting, delightful place to live. Round is I think a nicer atmosphere than rectangular, and yet really reduce the amount of material you're going to be using. So what we came up with was to do octagonal. You could do a 9 pentagram, or you could do a 6-sided. There's all sorts of various sides, but the 8-sided structure is the right size. We're taking these SIP panels as they come from the factory floor, which is 24 feet by 8 feet, and then attaching them in a way that creates this octagonal home. You could do it in many, many different ways. I started originally with the idea of a straw bale, but it turns out that straw bale was not good enough insulator to really get at having a net zero system.
Okay, and tell us a little bit about the gardens that line all of the different levels.
So these gardens were sort of inspired by a gentleman by the name of Pat Lando, who started a wall in his home with a garden. And Pat Bailey, who's part of Bioscape Pacific, and we came up with some ideas on how to take that concept and turn it into an actual product to test out, because it's so integral to the design of this home. You see the decking, the size and the shape is all dependent on trying to grow as much food as you can on the walls. And so we wanted to make sure that those actually work. So here we had a couple of these built by a volunteer.
And they're
King
vertical gardens?
Constructions.
They're called vertical gardens?
They are called vertical gardens.
Okay.
And they, a variety of people donated their equipment. Hunter donated their irrigation system. Ewing put in that design, or that system, created the design and built the way to irrigate. And Phillips Soil contributed the soil to put that into the units. Turns out that soil is really important. You can't have just regular soil because it will just run through. There's a special design here on the gardens that allow about a 2-inch gap between the wood structure and the wall. So you've got a trough, but doesn't have anything to hold the dirt in between. So it's just gravity and sort of a binding force that makes this work. And if you don't have that binding force, it all runs out.
So this would be a special type of soil that they would have to purchase, like spring soil, I think you've called it?
Yeah, it's
Okay.
called spring soil. It's by Phillips Soil, and it was a crucial part of this experiment. And basically, we in the spring we planted it and saw what resulted in it. And as you can see, we've got some glazing that is put over it to kind of create this greenhouse effect, so that it's nice and warm in the fall and the spring, and it doesn't use much water. And here are some shades in case it gets too warm. And then here are the results. So this is after 3 months of growing. You have these very plentiful gardens, and I was measuring a variety of different produce and what you can really grow. These turned out to be a little too big for the garden, but you can also now found that beets and certain size kale is a delight for it.
Okay, and how do they not rot? Bear with me on the material.
Right. So this material is called New Wood, and it's created by Boise Cascade, and it's based on plastic bags and sawdust. So it's 99.98% recycled material, and they're all just melted and created into a plywood that doesn't rot and is, I think, an ideal product for this type of a design.
Okay, and so you can use regular water, but I've also heard about a urinator, and so I need that explained a little bit more.
Right, the urinator, that's a little dispensing device that I used to start playing with the idea of how to get to net zero. You know, the net zero aspect, i.e. you're collecting all your own rainwater, but you're also processing your rainwater or your sewage basically on site. And we like to call it nutrients, actually, because there's a lot of great nutrients. Like urine itself has the perfect mix of potassium, nitrogen, and phosphate. Phosphate is something that's being mined at an unsustainable rate. We're going to have some real issues when that's gone. So why not put it back into the soil? It used to be done that way in earlier times in most cities in Europe and in Asia. They were collecting feces and urine and putting it under the fields in the nearby, and we've gotten away from that with the advent of the sewage system. So here we're trying to put back a great fertilizer, a fertilizer that's proved to be harmless, that's sterile when it comes out, and if you put it into soil right away, it's just a great food for the microbes and fauna in the soil.
Who would have thought?
Yeah, right. So that's a system that we're able to deal with all of the urine, and so each one of the toilets in the Earth Harmony habitats has a urine collector, has a urine separator, and that goes into a place that then kind of dribbles urine into these various systems as it's needed. and it can also go into the gardens. And you'd be surprised. There's not a urine smell. It's an amazing system that is part of the whole idea of sustainability.
Okay. So I'm just curious how your vision came about as a leader in sustainability. How did this even get started? How did you come up with this idea?
Well, that's a great question, Dory. What I took a course in Japan when I was living there, working for a certification company, and it was a course on environmental, on the environment, essentially. And it taught me a lot about where we are as a community, and the degradation of Earth, and really exposed me to the systems that are not running in a harmonious way, in a way that's sustainable. And so I, with my background in engineering, took on this education and got a master's in environmental decision making out of the UK, out of the Open University, and pursued work in standards, thinking that standards would be the way to increase the environmental concern and reduce the environmental impact. And after about 15 years, I noticed that nothing really tangible is coming out of that. It's too slow of a process and too political of a process to be effective. So in about 2007, I got involved with a natural step. I've got involved with some of the architects that were involved in this as well, and started hearing about LEED and the Living Building Challenge, which I want to talk a little bit more about, because a lot of the processes and a lot of the inspiration of Earth Harmony Habitats came from the Living Building Challenge. But so I just put a couple of things together and said, I bet you can get a net zero home with water and with energy, and let's grow all our own vegetables, because these are three major concerns. The building environment itself uses about 40% of or emits about 40% of our greenhouse gases, and 25% of our wastes are being generated from the construction industry. So being able to address those is a great way to really tangibly reduce our environmental impact. So I started taking classes on passive house, sustainable housing professional, energy assessment, LEED Green Associate, and started really educating myself on how do you create these buildings. I took the inspiration from Buckminster Fuller, who at one time said, "Dare to be naive." And I, decided to, that is how things get done. You go into things without knowing all of the challenges that you have ahead of you, and come up with unique ideas and really kind of shake up the industry, which has really been going in a certain direction that requires a utility bill and requires a heating cost and a water bill. And finding that now you've got all these natural systems that you can utilize for water and for energy, and why not use these? Why accept the conventional wisdom of the past?
Or the standards.
Yeah.
And kind of breaking away from that.
Right. So these challenge some of these ideas. The idea of 4 homes on a city plot, not it's sort of against code in most areas, especially when you get into codes of what they call R2, R5, R7. These are, R7 is 1 house per every 7,000 square feet. And R2 is 1 house every 2,000. So these can live in certain codes, R1, because it basically is 1,000 feet for every unit. But these are ways to help densify the community without adding huge apartment building structures, and help really attain some of the goals that the city wants to achieve. Partly being they want to be carbon neutral in 2050. They want to reduce their water consumption by 30%. They want to make walkable neighborhoods. you need to have density to make a walkable neighborhood. Otherwise, stores simply aren't interested in putting themselves there without enough people.
Right, and having more connected communities, and it seems like it just brings a sense of community just by even looking at it.
Right, right.
Yeah.
Well, and this is another part of the idea. I mean, this is a great way to survive economic downturn is through community. It's also a great way for people to connect with each other, for families to utilize some of the strengths of the elder group, and folks that don't have children, to be able to mix everyone together and create a small village.
There's such a need there, it seems.
Yeah.
Yeah. So tell me about the Living Building Challenge. You were kind of highlighting that a little bit.
Yeah, thanks. So the Living Building Challenge is a set of 20 different principles or imperatives to create a home that emulates nature, emulates a flower actually, and their emblem is a flower. It's a dandelion, and it utilizes many of the concepts that I've just mentioned. Plus, it also talks about and requires the use of no toxic materials, lead, cadmium, PVC. Polyvinyl chloride used quite a bit. That's vinyl, right? That creates a lot of dioxin when it's burned or when it's created. So it's addressing the toxicity that we're adding to the environment, the bioaccumulation of toxicity. And it also addresses equality, trying to make things affordable, community. So Earth Harmony Habitats, simply addresses all of those criteria, and they've got a new set of a standard called Living Building Community, and it's all about creating communities that meet the Living Building Challenge.
Right.
So
and
we hope to be the first certified living building community.
Wonderful.
In the planet, actually.
Portland
Yeah.
is hoping for that.
Yeah,
Wow.
well, Earth Harmony Habitats is.
Okay. And so as a leader, what is your hope in the sustainability culture? What's your hope for change? And
Well, sustainability is maligned or misused a lot. Everyone's kind of picked up that word and is everything from just a slightly better environmental aspect to, and it has become greenwashed in a way. So I define sustainability as that which lives within an equitable share of Earth's carrying capacity. So once we understand what Earth's carrying capacity is, which is still yet undefined, I think we can get we can get at sustainability, and that's my vision, is to live within our services of nature, but not take from future generations.
or overconsume.
Right, or
Or
over-consuming. So when we draw down those aquifers, we're over-consuming, we're taking away from future generations. And when we put too much greenhouse gases into the atmosphere that can't be naturally absorbed by the oceans and by the forests, we're giving pollution to the future generations.
Right.
So
Or the urban sprawl taking away natural space.
yeah,
So this actually is conducive to living within our natural space.
right,
These
right.
homes.
Yeah, and it's, we're looking at, each person living on 5 or 10,000 square feet of land, kind of taking that up, but not really producing much in that, other than grass, right? We can't really, well, now we can smoke it, but it's not normally the same kind of grass. So, so we're trying to, densify so we can become a much more, live within our footprint, our ecological footprint,
Right.
our equitable share of footprint.
Right. What would you like to say to the younger adults who are pursuing a career in sustainability or kind of maybe following your footsteps? How would you like to direct them or encourage them?
Well, there's a lot of work right now being done in the green building area where there's a lot of focus on how do you create materials and how do you utilize materials that are a lot less impact. I think the net zero energy aspect is a a big motivator. There's a lot of focus going on in that, so I would recommend that we look into that, that folks look into that area. There's a lot of challenges to that. There's a lot of the built environment already that can be retrofitted. That's a real challenge. If we had higher costs of energy, if we brought in a carbon tax, that would be the motivation to be able to pay for, on our normal accounting system, these type of insulative and airtight buildings with heat recovery ventilation systems. So,
what are some degree programs that a young student could look into to follow, to try to make a change?
There's the sustainability management classes. I know Merrill Hurst offers one, MBA in sustainability.
Okay.
There are, PSU has a sustainability certification program. OSU, I believe, has something similar to that. So
Okay.
lots of things.
Lots of opportunities.
Right.
Okay. Thank you so much for your time tonight and just sharing with us your vision and the Earth Harmony habitats.
Oh, it's been a pleasure.
Enjoyed learning.
And more information, www.earthharmonyhabitats.org.
Okay.
Great opportunity for anyone to get involved in. We're also looking for people to volunteer their time to do some R&D into these various ideas that are, about 50% done, but they got to be, researched deeper yet.
Okay, great. So this is David Burdick with Earth Harmony Habitats, and we'll have his information up on the screen for you so you can get connected and volunteer. Okay.
Thank you so much,
Thank
Dari.
you.
Thank you.